Hello students, welcome to Keystone Universe of Education. My name is Rohit and today we are going to do a quick revision of chapter number 13 Statistics of Math class 10. So before starting the chapter, if you look at this chapter from the examination point of view, this is a very easy and scoring chapter. यहाँ पे आप expect कर सकते हो 2 markers, 3 markers, 5 markers questions, in fact 1 marker questions, and this is a formula based chapter which is a very scoring chapter as I said. पर इस chapter में जहाँ पे हमको careful रहना है वो हमको calculations में बहुत careful रहना है, right? So how to do smart calculations, what tricks to use while doing the calculations, that is what we are going to see, and this is going to help you in this chapter, right? Now, before starting this chapter in class 10, this chapter statistics we have also studied in class 9, and we saw in class 9 statistics that this is a branch of mathematics which deals with data. So data की अगर हम बात करें तो data in today's life is very important. We know how important is data in today's life, right? So कोई भी बड़ा business हो, कितनी भी बड़ी कंपनी हो या छोटी कंपनी हो, data is very important for everyone to take informed decisions, to take very important crucial decisions based on data, right? In fact, अगर हम Keystone Universe of Education के कोई भी एक student के progress report को भी यहाँ पे देखें, so in this progress report we can see that the data is very beautifully represented, जहाँ पे we can see the performance of the students subject wise, we can see the attendance report based on percentages, we can see the assignment report based on percentages, and how beautifully on the basis of this data we can interpret and analyze this performance of the students, that the student is scoring quite well in math, English and chemistry but quite low in biology, right? So from this we interpret and analyze that student को biology में मेहनत करने की ज़्यादा ज़रूरत है. In fact, from this data we can also analyze that the 25% of the homework submission has not been given by the student, right? So we can see the data very beautifully presented here, but इसके backend में there is a lot of numbers, there is a lot of data which is working, right? It is organized in a way so that we can represent it in this way, right? So basis on this, once the data is represented, we can do the important analysis and interpretation. So when we talk about statistics, we can see that statistics is about first collection of data, second organizing the data, third representation of the data and this kind of report, and fourth is very important, that is the interpretation and analysis of that data, right? Moving further, talking about the data, so talking about the core content, the core topics of this chapter, we will discuss about a few terminologies, a few basic concepts that we have understood in 9th standard, just a brush up so that we can understand the questions, the topics that are going to come in the further chapter. So let us understand a few terminologies. First, let us talk about the ungrouped data. So what is ungrouped data? Ungrouped data is the data in its original form. It is the data in the raw form. We have just collected the data and dumped it and collected in any raw form. The observations here are not classified into the groups. So let us look at an example. This is an example of some students or some persons present in a classroom of kindergarten KG kids with the teacher. And if you look at the age of these persons, there is a kid whose age is 3 years, then 4 years, this way, and there is a person in this room who is also of the 27 years of age. So we can see that the ages of these persons are just collected and written here in its original raw form. So this data shows that there is one grown-up person, as we discussed, there is a one person who is grown up and that is of the age of the teacher present in that class. So the ungrouped data is easy to work when the data set is small. So when we have collected the data and the data size, the size of the data set is small, the ungrouped data can be. But अगर data set का size बड़ा हो, right, when there is a lot of numbers, right, so it becomes difficult to analyze, to organize the data, right, and for that reason it is very important that the data should be grouped. right? So for example, in group data, the observations are organized in groups. Now, why is it important to organize the data in groups? Let's take an example. Let's take an example of marks of some students in subject mathematics, and the exam is taken of 100 marks. Now, if the number of students here increase, let's say in a class 40 students, so the number of students here have increased. If we take the data of the students of the whole school, so वहाँ पे data numbers और बढ़ते जाएंगे, right? So it is not ideal here कि हम बहुत lengthy, long, ungrouped data के tables बनाएं, and that's why it is important कि हमारे जो numbers हैं उसको हम groups में form करें. In fact, a very important thing here that we should discuss here, that here the numbers that we have, the numbers that we collect as data are called observations. So this is the word we are going to use again and again. What are observations? The observations are the numbers that we collect as the data, right? Further, so as we discussed that in group data, the observations will be organized as groups. Let's see how. So we talked about the example of the marks of the students, and this marks of the students, the large data can be represented in the form of a table. So we have organized the marks of the students in the form of the groups here, and these groups of marks is also known as class interval, right? So we have grouped these observations and the number of students here. These are the number of students. So let's say 13 students have scored marks between 0 to 20, 9 students have scored marks between 21 to 40, and so on, right? Now, an important thing here to note is that for this kind of data, for the grouped distribution, frequency distribution, the classes have to be in the continuous form, right? So what is the continuous form that we are talking about? यहाँ पे जो हमने class intervals जो groups बनाए हैं, वहाँ पे if we look at the numbers here, if we consider any example of a class 0 to 20, 21 to 40, this is the kind of the groups or classes that we have here. And यहाँ पे कोई भी class interval का अगर मैं ये lower number देखूं तो this is known as lower class limit, and जो हमारा bigger number है उसको हमको कहेंगे upper class limit. So we have the lower class limit, we have the upper class limit. Now when we look at the distribution here, when we look at the groups, the classes here, so it starts like 0 to 20, and then 21 to 40, then 41 to 60, and so on. When we look at the number, the upper class limit of this class, this is 20, and the lower class limit of the next class is 21. So there is a huge gap of numbers between 20 to 21, as we know, right? So to eliminate this gap, we make the classes continuous so that there is no gap between the upper class limit of the previous class and the lower class limit of the next class, right? So जो भी हम डेटा यहाँ पे यूज करने वाले हैं, जो भी हमारा क्लासेस के फॉर्म में होगा, जो हमारे ग्रुप्ड फ्रीक्वेंसी डिस्ट्रीब्यूशन के फॉर्म में होगा, वहाँ पे हमारे क्लासेस का कंटिन्यूअस फॉर्म में होना कंपलसरी है, right? So let's look at an example of how the continuous grouped frequency distribution may look like. So it can be formed as 0 to 20, 20 to 40, 40 to 60, 60 to 80, and so on, etc. Right? Here in this continuous distribution, we can see that the upper class limit and the lower class limit of the previous class and the next class is same. Now, this is the data that we have formed. अगर हमारे पास ऐसा डेटा हो जहां पे हमारे लिए हमको उसको कंटिन्यूअस फॉर्म में कन्वर्ट करना हो, तो हम कैसे करेंगे? That we will look while solving the examples, right? Further, so this is an example of a grouped frequency distribution. This shows how many students got marks in a particular range, as we discussed. So grouped data is easier to work when a large amount of data is present. So when the data set is huge, large, the numbers are large, so we use the grouped frequency distribution, right? Further, So talking about the frequency. Frequency is the number of times a particular observation occurs in the data. So how frequently that particular observation is occurring again and again in the data, that is known as the frequency. Let's understand this through an example. So let's say we have an example again of the KG kids here with some ages, and if we want to tabulate this data, so we can see that the age of the persons present in the room is given. So if we consider the age of the students here, let's say there are some students whose age is 3 years, there are some students whose age is 4 years, there are some students whose age is 5 and 27. So the number of persons whose age is, let's say, 3 years, so we count the number of students whose age is 3 years, 1 2 3 4 5 6 7 8 9 10. So there are 10 persons, 10 kids whose age is 3 years. So this gives me the frequency, the number of persons whose age is 3 years, right? Same way, the number of persons whose age is 4 years is 4, number of students, number of kids 5 years is 1, and 27 also, there is just one person whose age is 27. So this is known as the frequency, and frequency is just the number of times the observations is occurring in the data. So class interval, talking about the class interval, as we discussed, the data can be grouped into the class intervals such that all the observations in the range belong to that class. So जो हमारे observations की frequency है, वो observation जो number है, कोई भी age है, so observations क्या क्या हो सकते हैं? So observations can be the age of the persons, it can be the height of the students, it can be the weight of the students, it can be the marks of the students. ये जो भी values हैं, इनकी range काफी ज्यादा होती है, इनकी जो लोअर लिमिट और अपर लिमिट वो काफी रेंज इनकी ज्यादा होती है. दैट्स व्हाई इट इज इंपॉर्टेंट कि हम उसको क्लास इंटरवल में डिस्ट्रीब्यूट करें. So talking about the class width. So class width is the height of the class interval actually. So let us understand this through an example. Let's consider again the data of the marks of the students where we have any classes here. Let's say these are the marks of the students and the number of students. This is any grouped frequency distribution where we have any number of students here, right? So if we take any class here, so we know that in this class the lower class limit is 0 and the upper class limit is 20. So your class width is given by the upper class limit minus lower class limit. So here class width, which we will represent with the help of h, which is the height of the class interval, will be 20 minus 0, 20 minus 0, and that will be equal to 20, right? So 20 minus 0 and h here is 20. So this is very important, where h will be used in many of the cases where we are calculating the our questions based on mean, median and mode, right? Further, now coming to the topics that are very important in this chapter. Now, how important it would be that I can summarize the whole data of the numbers that is given in some single digit, in some single number, not digit. So एक ऐसा मेरे पास नंबर हो जो पूरे डेटा का मुझे समराइज नंबर दे दे. ऐसा कोई वैल्यू हो, ऐसा कोई एवरेज हो, ऐसा कोई सेंट्रल नंबर हो, सेंट्रल टेंडेंसी हो, या ऐसा कोई मेरे पास नंबर हो जो बार बार रिपीट हो रहा है, right? So this number that is given in the data is a part of statistics which is known as measures of central tendency. And here in this chapter, the measures of central tendency that we are going to discuss is mean, mode and median. So let's understand these one by one. So mean is nothing but the average. So let me give you an example of mean. So let's say out of 80 marks in any particular exam, a student has scored, let's say in one of the subject the student has scored 72 marks out of 80 and 74 marks out of 80, in another subject 76, 78, and let's say in math the student has scored 80 on 80. So we have 5 subjects here, and the marks of the 5 subjects here are 72, 74, 76, 78 and 80. Now if I want to understand the average performance of the student, how has the student performed on an average, so I will find the mean marks. So mean marks is nothing but if we add all the marks of all the subjects and divide it by the number of subjects, we get the average marks, that is 76, right? So here to find the means average, right? So mean can be found for ungrouped data as well as group data. So talking about the mean of ungrouped data, here the numbers that we have as marks are our observations, and the number of subjects that we have is n, that is the frequency, right? So mean of n observations here we are talking about, which is given by the sign x bar denotes the mean. The sign x bar denotes the mean here. x1, x2, x3 and dot 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 xn, these are all the observations included in the data. N is the total number of observations. So mean for ungrouped data is adding all these observations, the sum of all these observations, right? The sum of all these observations divided by total number of observations. So this is given by sigma x upon n. Now the sign that you are seeing here, this is like e. This is called as sigma, and this denotes summation. This denotes summation. Summation means sum of all the observations in the data divided by the total number of observations, right? So this is the mean for ungrouped data, where we just add the numbers, where we just add the observations and divide it by the number of observations. Coming to the mean of grouped data. When we talk about the mean of group data, here we will have the data that will be given to us already in the form of the table. In this table, we will have already the classes and the frequency of those observations, right? So let's look at the mean of group data. So the mean of the group data can be found by the following 3 methods. So we have 3 methods here to find mean for the group data. Now, why are these methods? What are these different methods? So calculating mean by 3 different methods is not going to give you different answers, but different method is suitable for different cases, right? So when the number of observations or the numerical values of your observations and frequency are very small, there is a particular kind of method that will be used for mean. But when the numerical values of your observation and frequency is large, there is a different method of the mean that we are going to use. Now the purpose of using different methods here is to make the calculations easy, to save your time while doing the calculations, right? So in fact, your questions is going to ask you to use the appropriate method, to use the suitable method, right? And there, considering the numerical values of your observations and frequency, we have to decide which method to use, right? So let us look at these methods, and let us look at the formulas that is going to be used in 3 different methods. So first method to talk about is direct method. Direct method, the formula for direct method is given by sigma fi xi divided by sigma fi. Right, so here this method, in the numerator part we have sum of all the values of frequency multiplied by xi, and in denominator we have the sum of all the frequencies. So here very important thing to note for mean is the class marks. So it is assumed that the frequencies are centered at the midpoint of your class interval. So that's why we multiply the frequencies with the class mark, which is nothing but the midpoint of your class interval. And how do we find the class mark? So class mark is obtained by upper class limit plus lower class limit divided by 2. Let me explain through an example. So let's say we have any class which is 0 to 20, 20 to 40 and so on. So for this class 0 to 20, the class mark which will be our xi while finding the mean will be nothing but the upper class limit, that is 20 plus 0 divided by 2, that is 20 by 2, that is 10. Same way class mark for the class 20 to 40 will be 40 plus 20, that is 60, divided by 2, that is 30. So this is just adding the upper class limit and lower class limit, dividing it by 2, right? Further, so this is finding the mean by direct method. The another method to find mean, to make our calculations easier, is assumed mean method. In this method, we are going to assume one of our class marks to be the mean, one of the central value of the list of the observations, list of the class marks that we have, to be the mean, right? So now the name suggests that in this method, A is chosen, which is called the assumed mean. Somewhere in the middle of the values of xi, where xi is nothing but our class marks. One important thing to be noted here is that assumed mean has to be taken for from the class marks xi and not from fi, right? So assumed mean will be the value which is chosen from xi, that is class marks. So the formula, the mean by assumed mean, is given by x bar is equal to a plus sigma fi di divided by sigma fi. Here di is the deviations which is obtained, where di is equal to the value of xi minus a. Di is given by xi minus a. That means the values of class marks minus the value of the assumed mean that we have selected, right? Further, step deviation method. The mean by step deviation method is given by x bar is equal to a plus sigma fi ui this time divided by sigma fi into h, right? Where ui is given by deviation, that is xi minus a upon h, right? So here we will see how these methods will be used to make our calculations easier, how these methods will be applicable to find the mean of the data. So let us go through an example, and one of the examples where we will solve all three methods and see that the value of mean that we obtain is the same by all three methods, but which suitable method to select, that we are going to see in the further examples. Let's move further. So we have a question here, an example that says, the table below gives the percentage distribution of female teachers in the primary school of rural areas of various states and the Union Territories of India. Find the mean percentage of female teachers by all three methods. So this is rarely going to be asked that you have to find the mean by all three methods, but we have taken this example to understand how do we find the mean by all the methods. So we have the data here, which is in the tabular form. We have the percentage of female teachers given in the form of the classes. Very important here, you check whether the form, that is classes, are in the continuous form or not. If it is in the discontinuous form, you first convert it into the continuous form and then start the question, right? So if we see 15 to 25, 25 to 30, the upper class limit of one class is same as the lower class limit of the next class. So that's why this data is in the continuous form. This is a continuous grouped frequency distribution. So we can move further with the data, and the number of states or union territories are given in the form of frequencies. So in these type of questions, you will be given a table which will contain just two information, observations and the frequency. How we will tabulate? So we have the first column, which is the percentage of female teachers, which are our classes, and number of states or union territories. These are our FI, that is frequencies, right? Now coming to XI. So as we discussed, XI here for the mean will be the class marks, right? So these are our class marks. And what are class marks? Class marks is nothing but the upper class limit plus lower class limit divided by 2. So considering the first class, that is 15 to 25. So if we want to find the class mark of this class, so 15 plus 25, that is 40 divided by 2, we will have 20. 25 to 35, we will have 60. 60 divided by 2, that is 30. And now we can pick the trend here that the difference between the two class marks will be 10, and we can fill the table very quickly basis on this. So next is 40, 50, 60, 70, 80, and the total here that is given 35. This is nothing but the sum of our frequencies, which is sigma fi. So sigma fi here we have, that is 35, and we have all the class marks also listed now. Now next column that we have is of DI, that is deviations. Now deviations will be used for two methods, that is assumed mean and also the step deviation method, right? So deviation considers the assumed mean. Now here it is important that we take assumed mean from the xi, that is the class marks. It can be any value from the center. It is not that if you take the first or the last value as assumed mean and you will not get the answer. We take the central value because it makes our calculations easier, right? So because this is assumed mean, we will take any assumed mean, that is the central value here as 50 as our assumed mean, right? So how we get the deviations? We subtract the assumed mean from all the class marks that we have. So for the first row that we have, the class marks is 20. So 20 minus 50 will give me minus 30. 30 minus 50 will give me minus 20. So this will be minus 10, 0, 10, 20, and 30. Right? So we have got the column of the deviations ready for us. Further, next is ui. Ui is equal to xi minus assumed mean upon h. Now here the height, h is the height of the class interval, and if we check h, which we discussed, the class width is nothing but the upper class limit minus the lower class limit. So 25 minus 15 is 10. Same way 35 minus 25 is 10, and we understand here that the height is 10. So we have the column of ui where we will calculate these values. We have already calculated the values of deviations that we have di upon. We will just divide these values by 10 and we will get our values for this column. So this will be minus 30 upon 10. This will be minus 3, minus 2, minus 1, 0, 1, 2, and 3. Right? So starting first with the direct method, to find the mean with the direct method, the formula that we have is sigma fi xi divided by sigma fi. So we already have the value of sigma fi here, that is 35. Now we need the column of fi xi. Fi multiplied with the class marks. So we have the column of fi ready with us, we have the column of xi ready with us. We will multiply these values to generate the column of fi xi. So let's multiply these values. 6 into 20, 120, then 11 into 30, then 7 into 40, 4 into 50, 4 into 60, then we have 2 into 70, and lastly we have 1 into 80. Now we need to add, to find sigma fi xi. Sigma means summation, and we need to add sum all the values of fi xi. So let's add these values. We get not for 12, not for 16, 24, 27, 29, 2 carried, 6, 7, 8, 9, 10, 11, 12, 13. So we have got the value, the sum of all the values as 1390. This 1390, that is our value, which is sigma fi xi. Right? Now, how to find the value of the mean by direct method is we need to use these value of sigma fi xi and we need to use the value of sigma fi, right? Okay, let's first generate all the columns here, and let's see the values of fi di and fi ui also. We will use these values to find the mean by different methods, right? So next column is fi di. So frequency multiplied by the deviations, right? So 6 into minus 30, that is minus 180. 11 into minus 20, that is minus 220. 7 into minus 10 minus 70, 4 into 0 0, 4 into 60 240, 2 into di, that is 20, 2 into 20, that will be 40, and here 1 into 30, that will be 30. Right? So here to find sigma fi di, we will do the summation of all these values. So here the values that we have, plus 70 minus 70 gone, and we have the value 240 and minus 220, that will be plus 20, and here the value that we will obtain, plus 20 minus 180, that will be minus 160. Let us check the values once. So 6 into minus 30, that will be minus 180. This is FIDI column, right? 11 into minus 20 minus 220, 7 into minus 10, 4 into 10. See here, we have made this mistake here of multiplying the values of the columns. As you can carefully see here, we are doing Fi multiplied with the Di. So 4 into 10. So it is suggested that once you have calculated all the values, once you have listed all the values, just cross check the values so that these kind of mistakes can be avoided and you get the correct final answer, right? So here when we multiply 4 with 10, instead of 240, the value here will be 40. So our final value of sigma fi di will change here. And let's again check. 2 into 20, that is 40, this is correct. 1 into 30, that is 30, right? So this is the sum that we will do here. 40 and 30 minus 70 gone, and here minus 220 plus 40 minus 180, minus 180 minus 180, this will be minus 360. This is the value of sigma Fi di, right? Next, the column is Fi ui. So we will multiply the values of frequency with the ui's here, and this is nothing but this column is nothing but Fi di, that is the deviations wala column, divided by 10. So we will have all the values divided by 10 here, and this will be equal to 6 into minus 3, that will be minus 18, then 11 into minus 2 minus 22, then we have 7 into minus 1, that is minus 7, 0, then 4 into 1, that is 4, again 2 into 2, that is 4, and 1 into 3, that is 3, and we will do the summation of all these values again, and we will get the value, that is minus 36, and this value will be our sigma Fi ui, right? So we have all the required values in this table to find the mean by all three methods. Direct method will take sigma Fi xi as the value, then assumed mean method will take sigma Fi di as the value, and step deviation method will take sigma Fi ui, that is minus 36 as the value, and we have the common value, that is 35 sigma Fi for all the three methods here, right? So further, so if you look at the all the three methods, let's try to get the mean from these methods. So from the table above, we have these values. We have sigma Fi, we have sigma Fi xi, we have sigma Fi di minus 360, and we have sigma Fi ui as minus 36. So by direct mean, by the direct method, let's find the mean. So mean is given by sigma Fi xi divided by sigma Fi. So the value here is 1390 divided by sigma Fi, that is 35. Now it is required that you do these calculations very accurately, right? So we have to divide the numbers here, and it is suggested in boards exams also that you develop a separate column on the right hand side of your supplementary to do the calculations neatly, right? Keep your main supplementary neat and clean, so and do your rough work, that is the calculations, by drawing a column on the right hand side, right? So we divide these values, 1390 divided by 35. So we have here 35 3s are 105, and the value here will be, taking this down, and we have 35 9s are 315, we have the value here 25, and a decimal and let's calculate 35 sevens are, so 35 sevens are, we will have 7 5s are 35, this will be 245, and we have the value here, that is 5, and one more 0, 35 ones are 35, and we can go up to 2 decimal places here. Up to 2 decimal places the value, your answer will be considered, and the value that we have obtained here for the mean is 39.7. Right, so this is the value of mean that we have obtained by the direct method. Going further, using the assumed mean method to find the mean, we have the formula is x bar is equal to a plus sigma fi di divided by sigma fi, and here the values, the assumed mean that we have taken is, let's check the value of the assumed mean that we have considered. The value of assumed mean is 50, so let's take this further. So 50 plus we have the value of sigma fi di, that is minus 360 divided by sigma fi, that is 35, and when we calculate this value we get 50 plus minus 10.29, and again this will give us the same value, that is 39.71. Right, so we have found the mean by both the methods, direct method and the assumed mean method, and here in assumed mean method we have seen that the calculations that are done here, it saves time, it is quite simpler than finding the mean by the direct method. Taking this further, we have the step deviation method. The formula is x bar is equal to a, that is assumed mean, plus sigma fi ui upon sigma fi into h. Right, so this value of a that we have, assumed mean was taken as 50, sigma fi ui, the value was taken as minus, that we obtained was minus 36, and the height, that was the class width, is 10. And again we will have the value here, that will be 50 plus minus 10.29, and when we subtract these values we again get the value 39.71. So as we see here that the value that we obtain for the mean by all the three methods is same, that is 39.71, and here the mean percentage of female teachers in the primary schools of the rural areas is 39.71. This is the conclusion that is compulsorily required to be written at the end of your answer. So this mean is what? This mean is nothing but the mean percentage of the female teachers. That is what at the end of the answer you have to write as the conclusion. Right? So now going further in these examples, we are going to see, just a second. So going further, we are going to see the how to find mean for different type of data sets. So we will see here when the numerical values will be small, we will use a different method. When the numerical values will be greater, we will use a different method. Let's see. So next example that we have is, a survey was conducted by a group of students as a part of their environment awareness program, in which they collected the following data regarding the number of plants in 20 houses in the locality. Find the mean number of plants per house. Which method did you use for finding the mean and why? See, here it is very important to use the appropriate method. If for this particular kind of data set we use the step deviation method, it will increase the number of columns and increase our time also to calculate all these values, right? So as we can see here, the data 0 to 2, 2 to 4, 4 to 6, the numbers are very small. In fact, the numbers given in the frequencies, these are also very small. So we should select a method that saves our time. So for such small values we will use the direct method here to find the mean, right? So let us solve the problem by direct method, and the mean by direct method is given by sigma fi xi divided by sigma fi. So we need a table with the values. The table that is already given to us, we will populate those two columns, and then we will find the xi, that is class marks, and then we will find the column of fi xi. So we have the number of plants here, we have the number of houses here. Here the number of houses is our frequency. Next column will be the xi, that is the class marks. So class marks is nothing but the upper class limit minus lower class limit divided by 2. So here 2 plus 0 divided by 2 is 1. See the values that we are getting, how small they are. So it definitely saves our time. And we have obtained all the values of the class marks here. Next column that we have is fi into xi. So we are generating that column here. 1 ones are 1 and so on. We are just multiplying these values. 2 into 11 22 and 3 13s are 39. So we have all the values of fi xi here. Now we will find sigma fi xi, that is the sum of all these values. 9 into 11 4 15 25 and 25 and 6 31 and 1 32, 3 carried, 6 11 13 and 16. So we have the value, the sigma fi xi, the value that we have obtained is 162, and the sum of all the frequencies here 3 4 and 9 15 and 5 20. We already have here the value of 20 houses, and we have the value of the sum of the frequencies as 20. Right? So calculating the mean by direct method, we have the formula sigma fi xi upon sigma fi. So this will be 162 divided by 20, and we do the cutting. This will be 81 upon 10, and the value, the final value will be 8.1. So here there's a mean number of plants here is 8.1, and as we discussed, the method used here for is the direct method, because the numerical values of the xi and fi are very small, right? So it is not appropriate here to use the method of step deviation as you mean. That will increase the number of columns and it will not save our time as this. Clear? Let's see further the next example. Next example, the following distribution shows the daily pocket allowance of a children of a locality. The mean pocket allowance here is 18. So we are already given the mean pocket allowance, that is the mean is given to us is 18. Find the missing frequency f. So these are the kind of questions that are frequently asked in your exams, to find the missing frequency kind of questions, right? So how to solve this particular question, how to find the missing frequency here? We will use the value of the mean that is already given to us, that is 18. So the mean pocket allowance is already given to us, that is 18. Now here the method that we are using is assumed mean method, and you can use any method to find the missing frequency. Here we are considering the assumed mean method. So we have the table here, we have the daily pocket allowance, that are the classes, and we check that the classes are continuous here, and the number of workers that are given to us are the frequencies. So let's start solving this sum with the help of assumed mean method. Here first we have the xi column, which are the class marks. So class marks is the mid value, right? So 11 to 13, we have 13 plus 11, that is 24 by 2, that is 12. Same way, next is 14. Let's list down all the values of the class marks very quickly. Here this is quite simple, and we have all the values of the class marks. Now the next is di, that are deviations, and here we will take an assumed mean a, which is here considered to be as 18. So this is one of the central values, and we consider 18 is our assumed mean. And let's list down the values of deviations. So we have xi, that is 12 minus 18, we have minus 6, we have minus 4, we have minus 2, 0, and we have 2, 4 and 6. Now calculating the values of FIDI, which is going to be used in our formula. So 7 sigma minus 42, we have minus 24, we have minus 18, and we have 0, we have f into 2, that is 2f, we have 5 4s are 20, and we have 4 6 are 24. Now sigma FIDI, that is the sum of the values of the FIDI. So we have 24 and negative 24 gone. We have 20. Here we have minus 18, and this will be positive 2 minus 42. That will be minus 40. So we have 2f minus 40. That is our value of sigma fi di, right? And we have sigma fi here. So let's calculate all these values. This will be f plus something, right? So let's add up all these values quickly. So we have 9 and 13 22, and 9 31 and 6 37, and 7 we have 44. So we have the value of sigma fi as f plus 44, and sigma fi di is 2f minus 40. Now we have all the values required to find the missing frequency. So let's substitute these values in our formula, and let's find out the missing frequency. So we have the value of mean here 18, and using the assumed mean method here, as we found all these values, sigma fi di is minus 40 plus 2f, sigma fi is f plus 44. So using the assumed mean method, the formula is x bar is equal to a plus sigma fi di divided by sigma fi, and the value is 18, that is of mean, right? In fact, the assumed mean that we have considered here, the value is 18 only, right? So here we have on the both the sides of equation, we have 18 here, and in middle we have sigma fi di upon sigma fi. So we will transpose 18 on the other side, that will give us 18 minus 18, and here on the RHS part, 18 minus 18 gives us 0, right? So we have minus 40 plus 2f upon 44 plus f, which is equal to 0. We will transpose this, and multiplying with 0 will give us again 0. So the value of minus 40 plus 2f should be equal to 0, right? So 2f should be equal to 40, and the value of f will be equal to 40 divided by 2, that will be equal to 20, right? So here the missing frequency that we have, the value of f that we have is 20, right? This is how we will find the missing frequencies of the given data, right? Further, let's look at the next example. In a retail market, fruit vendors were selling mangoes kept in the packing boxes. These boxes contained varying number of mangoes. The following was the distribution of mangoes according to the number of boxes. Find the mean number of mangoes kept in the packing box. So again, we are finding the mean here, and if we look at the data, the number of mangoes are distributed in the classes, and if we look at the class intervals, we have 50 to 52, 53 to 55, 56 to 58, and so on. Here one important thing to notice is that the classes are not in the continuous form, right? See, the upper class limit of the previous class and the lower class limit of the next class are not same, right? So we have to convert this kind of discontinuous frequency distribution to continuous group frequency distribution. So how to convert this? So we will take the value of the upper class limit, we will add 0.5 here to the upper class limit and subtract 0.5 from the lower class limit, right? So by doing this, we will be able to get the same values of the upper class limit of the previous class and the lower class limit of the next class. And let's generate the table here as we discussed for the classes. So we have the number of mangoes now, and in this column, as you can see, now the classes have become in the continuous form. So if we look at the values here, 52.5, 49.5 to 52.5, 52.5 to 55.5. How did we do this? We subtracted 0.5 from 50 to get 49.5. We added 0.5 to 50 to get 52.5. Same way for the next class, same way for the next class. And as we can see, the upper class limit and the lower class limit of the continuous classes are same. Now we have the number of boxes, that is the frequency listed here as we have in the data, right? Now the next column that we have is the class marks, that is xi. So class marks is nothing but the upper class limit plus lower class limit divided by 2. So this will be 49.5 plus 52.5 divided by 2, that will be 102 2 divided by 2, that will be 51. Same way, next should be 54. Same way, next should be 57. Next should be 60. Same way, next should be 63. Right? So we have all the values for the class marks here. Now the next column is DI, deviations, that is xi minus a. A is nothing but assumed mean. So we are taking here assumed mean to be the value of 57. Right? So let's find out the values of the deviations here. So 51 minus 57, that will be minus 6. This will be minus 3, 0. Then we have 3 and we have 6. Right? Now this is the question that we are solving with the help of the assumed mean method. As you can see, the values from 51 to has become to minus 6. So how easy now it will be for us to multiply the values, to add the values and deal with the numbers. Right? So next column is fi into di. So we multiply the values of frequency with the deviations. So 15 6, so this will be minus 90. We have 110 into minus 6, that will be minus 330. This will be 0. Next is 115 into 3, that will be 345, and 25 6, we have 150. Now the next is sigma fi di, that is the sum of all these values that we have here, and as we can see here, the difference of this two will be positive 15, the difference of this two will be positive 60, and the value here that we will obtain is 75. Right? Next is sigma fi, that is the sum of the values of the frequencies. Right? So here let's add up these values quickly. So we have 5 and 5, 20, and 2 3 4 7 7 1 8 8 and 2 10, again 1 carried, and 1 2 3 and 4. So sum of all the values of the frequencies that we have here is 400. Right? So we have all the required values now to calculate the mean by this assumed mean method. Right? So let's move further, and here we have all the values, and the formula to find the mean by assumed mean method is a plus sigma fi di upon sigma fi. So here the assumed mean that we have taken is 57 plus sigma fi di, that is 75 upon 400. Right? So this should be equal to 57 plus, we have to divide 75 by 400 to get our value here. And one important calculation method that is to be noted here is, don't make the mistake of taking the LCM here. That will increase your time of doing or completing the calculations. Right? So here what we should prefer is solve this fraction first and write the value of this fraction up to 2 decimal places is fine, and write the value of that decimal form of that fraction here and add it with the number that is given as assumed mean or whatever number is given here, and you add those values to find your answer. Don't take LCM here in such kind of questions. Right? So 75 upon 400. So if we do the calculation by 25, so we have 25 3s are 75, we have 25 16s are. So we do the calculations again. As you can see, we will have a rough column here to do our calculations. Right? Make a habit of making this rough column on the right hand side of the page, which is also very necessary for your board exams. Right? So we have 3 divided by 16. Let's perform this division very quickly. So we have 16 zeros are 0, and we have decimal here. So we have 16 ones are 16, and the value here will be 14, and again putting a 0 here, we have 16 8s are 128, and the value here that will be 120, and we have 16 7s are 112, and whatever remainder we have here. So we have found the value up to 3 decimal places here, and we have 57 plus 0.187, that can be rounded up to 2 decimal places, and we can write the value 57.1 57.19. That is the value that we can have as our mean here, right? So we have found the mean here. The mean number of mangoes in the packing box is 57.19. So as you can see how quickly we were able to generate these values and how we use the method of assumed mean to find the values here. As discussed, don't consider LCM. Taking LCM here, solve this fraction, get it into the decimal form and add the values to get your answer quickly, right? Moving further now, the next question that we have is, the table below shows the daily expenditure on food of 25 households in a locality. Find the mean daily expenditure on food by suitable method. So as we discussed, which suitable method can we use here when we look at the numerical values of the observations? See the daily expenditure, those are our observation in rupees. So that is 100 to 150, 150 to 200. First of all, the classes here are in the continuous form, no problem in that, and the numerical values are very large, right? So we should consider using the step deviation method here to find the mean. Right, so we have the columns here, we have the frequencies, we have the classes, right? So using the step deviation method here, and we have the column of the daily expenditure in rupees, we have the number of households, that is nothing but our frequencies. Again coming to the column of the class marks, which is nothing but the upper class limit plus lower class limit divided by 2, right? So for the first we will generate the values of the class marks here, and 100 to 150, the mid value here will be 125, then we have 175, then these are quite easy values to get, and lastly between 300 to 350 we will have 325. Now here as we can see the class marks, the values are quite large, huge, so we will use the UI here and we will use the step deviation method here, where we consider UI, which is deviations divided by height of the classes. So deviation is given by xi minus a. So we consider here assumed mean to be 225, right? So this is our assumed mean here from the xi's we have considered, and UI upon xi minus 225 divided by height, that is the class width, which is given by upper class limit minus lower class limit. So this should be equal to 50 here, right? So let's consider these values. So we have 125 minus 225, that will be minus 100 divided by 50. So this value will be minus 2. Again 175 minus 2 minus 50 divided by 50, that will be minus 1, 0. So 275 divided by minus 225, 50 divided by 50, that will be 1, and 100 divided by 50, that will be 2. We have got all the values of the UI column here, and see the values, these are so small now to calculate, so small to multiply, so small values that will be considered for adding also, right? So 4 into minus 2, that will be minus 8, 5 into minus 1, that will be minus 5, 12 into 0, 0, we have 2 ones are 2 and 2 twos are 4. So we have all the values here in FIUI. Now sigma FIUI is just the summation of all these values. We have minus 13 plus 6, and this value will be equal to minus 7. Right? Further, we have the sigma Fi, that is sum of all the values of the frequencies. So we have the 25 households. Let's check this. 5 and 4, 9 and 12, 21 and 4, we have 25. So we have all the values required here to find the value of mean by step deviation method. So let's substitute the values and let's write the formula first. We have mean x bar is given by a plus sigma FIUI divided by sigma FI into h. So this should be equal to, what is our value of a, that is assumed mean is 225, plus sigma FIUI, the value is minus 7 upon, what is the value of sigma FI, that is 25, into h, height of the class interval, that is 50, So when we do the calculations here, we have 25 ones are 25 twos are 50, and we have 25 plus we have minus 7 into 2, that is minus 14, and this is 225 minus 14, which gives us 211 as our final value of the mean here by step deviation method. And here the mean daily expenditure on food is rupees 211. Right? So we saw here how to find mean with all the three methods: direct method, assumed mean method, and step deviation method. Right? So a suitable method has to be considered while finding the mean in a grouped frequency distribution. Now the next measure of central tendency here is mode. We saw mean. What was mean? Mean was the average of the data, right? So what is mode? Now mode for the ungrouped data is the value of observation having the maximum frequency. So this is how we find the mode for the ungrouped data, जहाँ पे डेटा में जो भी ऑब्जर्वेशंस है उसमें सबसे ज्यादा बार जो ऑब्जर्वेशन रिपीट हो रहा है, जिसकी सबसे ज्यादा फ्रीक्वेंसी है, that is mode for the ungrouped data. But that is not the same case for the group data. So यहाँ पे group data में how do we find mode? Let's look at this. So for the group data, mode की formula है, and how do we find mode? Mode is given by L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into H. Now, what is F0, what is F1, what is F2, what is L, what is H? Let's look at these one by one. So here in this formula, L stands for lower limit of the modal class. Now we are going to talk about the modal class here frequently. So first let us understand what is the modal class. So modal class for any given data, any given grouped frequency distribution, modal class is the class with highest frequency, the class with the highest frequency. So let's consider any data of marks of the students, and 0 to 20, 20 to 40, 40 to 60, and 60 to 80. Let's consider this data where the marks of the students is our observations, and we have some of the number of students as our frequencies. And let's say the student scoring 0 to 20 is 5, we have 20 to 40 is 7, we have 40 to 60 is 11, and 60 to 80 is 9. Let's consider this example as our data set. So in this particular frequency distribution, we can see that the highest the highest frequency of is in this data set is 11. So the class for this particular highest frequency is 40 to 60. So the class with the highest frequency is 40 to 60, which is our modal class. Right? So here L is the lower limit of the modal class. So in this case, the L, that is lower limit of the modal class, that will be 40. So F1 is the frequency of the modal class. So we will list here in our table itself the values of F0, F1 and F2. Let's try to understand this. F1 is the frequency of the modal class. So we have selected 40 to 60 as our modal class. So the frequency of this class will be F1. So 11 is the value of our F1. Next, F0 is the frequency of the class preceding the modal class. So our modal class here is 40 to 60. So the preceding class is 20 to 40. So the frequency of this class will be our value of F0. F2 is the frequency of the class succeeding the modal class. मतलब F2 वो frequency है जो modal class के बाद वाले class की frequency है. So modal class is 40 to 60. इसके बाद का जो class है वो है 60 to 80. And here the frequency is 9, which is F2. H is the size of the class interval, that is height of the class interval. right? So we are clear with the elements of this formula. We are clear that L is the lower limit of the modal class, F1 is the frequency of the modal class, F0 is the frequency of the class preceding the modal class, F2 is the frequency of the class succeeding the modal class, and H is the height of the class interval, right? So let's look at examples and try to find the mode of a grouped frequency distribution. So we have an example here. A survey conducted on 20 households in a locality by a group of students resulted in the following frequency table for the number of family members in a household. Find the mode of this data. Now, if we look at this data, we have the family size, which are our class intervals, and the number of families are our frequencies. So in this data, we have the classes, we have the observations as well as frequencies. And to find the mode here, the formula for the mode is given by L plus F1 minus F0. So let's list down the values here, but before that, the important thing here is to find the modal class. So to find the modal class, we must look at the class with the highest frequency, that is the maximum class frequency is 8, and the class corresponding to this frequency is 3 to 5. So the modal class here will be 3 to 5, right? So now we have the modal class. So let's look at the values. So modal class is 3 to 5. Lower limit of this modal class is equal to 3. The class size H is upper limit minus lower limit, that is 5 minus 3, that is equal to 2. Frequency F1 of the modal class is 8. Frequency F0 of the class preceding the modal class is 7, and frequency F2 of the class succeeding the modal class is 2. Now we have all the values required to be substituted in our formula. Let's use these values to find the mode of this grouped frequency distribution. So let's list down these values here first and then use these values. So what values do we have here? We have L is 3. In fact, let's write these values in our table itself so that it becomes easy for us. So here 8 is our F1, 7 is our F0, 2 is F2, and this is our modal class. And further, so moving further, we have the next. Let us substitute these values in the formula, and the formula is given by L plus F1 minus F0 upon 2F1 minus F0 minus F2 into H. Let's substitute these values. So L is the lower limit, that is 3, plus F1, that is 8, minus F0, that is 7, upon 2F1, 2 into F1, that is 2 into 8, minus F0, that is 7, minus F2, that is 2 into 2. So this should be equal to 3 plus 1, 8 minus 7 is 1, upon 16 minus 7 minus 9, 16 minus 7 minus 2, that is 16 minus 9, that is 7, into 2, that is 3, plus 2 upon 7, and we will find the value of this fraction. As we discussed, to solve this, don't find LCM. Instead of LCM, find the decimal form of this fraction and add it in this number to make your calculations easier, right? So as we discussed, we'll draw a rough column on the right hand side and find the value of this 2 upon 7. So we have zeros are 0, and we have 7 2s are 14, we have 7 8s are 56, and we have 7 7s are 7 6s are 7, 5s are 35, and we have 0 7 7s are 49. So we'll take this up to 3 decimal places, and this is equal to 3 plus 0. Let's take this up to 3 decimal places, and the final value that we will have is 3.286. Right? So the mode of the given data that we have is 3.286. So we listed down the values that are required for the formula. We substituted the values, we solved this, and the calculations are to be solved. The question is to be solved in such a way that the calculations become easy for you. Right? Moving further, Let's look at one more example to find the mode of a grouped frequency distribution. The marks distribution of 30 students in a mathematics examination are given in the table. Find the mode of this data. Also compare and interpret the mode and the mean. So this is the data from example number 1, where we already found the mean. Now we will find the mode and we will see the comparison of mode and mean and interpret this data on the basis of the answers that we get. So we have the data simply here, class intervals and the number of students are given as our frequency. So in this data, the first thing that we will list here, the maximum number of students, that is the highest frequency, is the maximum number of students in a particular class is 7, have got marks in the interval. So the class interval corresponding to this highest frequency is 40 to 55, which is also our modal class. So what is modal class? Class with the highest frequency. So we have the modal class here 40 to 55. Now let's list down the values here that are required. So lower limit, that is L here from the modal class, is 40. The class size, that is the upper limit minus lower limit here, is equal to 15. The frequency f1, so this value 7 is our f1, this value 3 is our f0, this value 6 is our f2. What is f0? The frequency of the class preceding the modal class. F2 is the frequency of the class succeeding the modal class. So F1 here is the highest frequency, and F0 is 3 and F2 is 6. Right? So we have all the values required here to be substituted in our formula. Let's substitute these values now in the formula. So we have the formula here, and let's again write down the values here so that we do not make any mistake while substituting these values. So the value is the modal class is 40 to 55. In fact, these kind of questions are also expected in your objectives, where you will be asked to find the lower limit of the modal class and add it with some other value, right? So these kind of questions are also included in the Keystone's objectives book, where such kind of objectives are expected, right? So we have the distribution here and the formula of the mode here, right? So L, the value of L is 40, we have the value of F1, that is 7, and such is the pattern that we use in our Keystone Power book, where once we have understood the method, it is just about the calculation part that have to be taken care, right? So here we will look at the values that are to be substituted here carefully. So the value of F0 is 3, then twice F1, that will be 7 2s are 14, minus F0, that is 3, and F2, that is 6, into height, that is 15, right? So let's calculate these values here. So this should be equal to 40 plus 7 minus 3, 4 upon 14 minus 3 minus 6, that will be 14 minus 9, that is 5, into 15, and this should be equal to 40 plus 5 3s are 15, 4 3s are 12, so 40 plus 12, that value comes out to be 52. So here this should be, the final value should be equal to 52. The value of mode marks, so the mode marks here is 52. And the mean marks that we found for this particular question was 62. So how do we interpret this data? So here the maximum number of students, so mode talks about the number of observations, right? So maximum number of observations that were having this particular range, right? So the maximum number of students obtained 52 marks, while on an average the student obtained 62 marks. So अगर हम average देखें, mean talks about average marks, and average marks was 62, while the mode marks, मतलब इतने marks maximum number of students क्या है, that is given by the mode. So mode marks here is 52 and the mean marks here is 62. Moving further with the next measure of central tendency, that is median. Now median in general sense is the middlemost observation. So once we have collected the data, we organize that data in some form. So it can be organized in some ascending form, or it can be organized in the descending form, right? Once we organize the data in the ascending or the descending form, we select the middlemost value, right? So it is very simple to do it for the ungrouped data. And to find median for the ungrouped data, we have certain formulas, and we also find the median for, we will also see how to find median for the grouped frequency distribution. So for ungrouped frequency distribution, median is nothing but the middlemost observation, and how to find the middlemost observation, how to find median for the ungrouped data. So median is the measure of the central tendency, which gives the value of the middlemost observation, which gives the value of middlemost observation in the data. So median for the ungrouped data, let n be the number of observation here. So if the value of the number of observations is odd, let's say we have the marks of subjects in your exam. So let's say you appear for 5 subjects in an exam, right? So here the number of subjects, that is 5, which is odd, which is an odd number. So if we are talking about ungrouped data where the number of observations is odd, so median is given by n plus 1 upon 2th observation, right? But it is not necessary that the number of observations will always be odd. It can be even also. Let's see. Let's say now we are calculating the median for marks that examination. You appeared for 6 subjects. So now the number of observations is 6, which is even. Now for this case where we have the even observations, so even number of observations, median is given by n upon 2th observation plus n upon 2 plus 1th observation divided by 2. This is the way, this is the formula by which we can find the median for ungrouped data, right? Now let's look at how do we find the median for the group data. So now for ungrouped data, first arrange the observation. As we discussed, the observations have to be organized either in the ascending form or the descending form, right? So for ungrouped data, this is the condition that has to be applied. Moving further, let's look at the median for grouped data. So we have a formula here. We have again a formula to find the median for the group data. So which is given by median is equal to L plus n by 2 minus CF upon F into H. Now here, let's look at the elements of this formula one by one. Here we have L is the lower limit of the median class. Now, as we look at the modal class, what was modal class? Modal class was the class with the highest frequency. So what is median class here? How to identify the median class? So here, the median class is nothing but the class with CF greater than n by 2. Now, what is this CF? CF stands for cumulative frequency. In a few minutes, we are going to understand what is CF, what is cumulative frequency, that is to be considered here for the formula of median. So here L stands for the lower limit of the median class. We have n is the number of observations, right? So CF is the cumulative frequency of the preceding class. So we will populate a data and we will list down the values of the CF, that is cumulative frequency, and the cumulative CF value that we will consider will be the value of CF which will be for the class preceding the median class. And F is the frequency of the median class, right? H is the height of the class interval. Now let us understand what is CF, that is cumulative frequency. Let's consider here some raw data. We have the values here 1, 2, 2, 3, 4. These are some values between 0 to 5. We have some values here 6, 7, 8, 8, 9, 9. These are some values between 5 to 10. Again, further we have these values between 10 to 15, and we have the raw data here. And if we develop a class interval here for this observation, right? So to is in particular raw data observations को अगर हमको एक grouped form में अगर बताना है, so we developed the class intervals here, and let's count the number of values here coming in this class interval. जो भी observations हमारे 0 to 5 के बीच में है, उतने number of values, that is the frequency of those observations, we write it here, right? So यहाँ पे कितने numbers हैं? Let's count it 1, 2, 3, 4, 5. So we have 5 observations in the class interval 0 to 5. Same way, let's count for 5 to 10. So these are all the values between 5 to 10. 1, 2, 3, 4, 5, 6, 7 and 8. Right? So again, between 10 to 15. 2, 3, 4, 5, 6. Next, between 15 to 20, we have all these remaining observations. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have developed a frequency distribution here. In fact, we have developed a grouped frequency distribution here. Now, while talking about CF, that is cumulative frequency, we will talk about two types of CF. That is a less than type CF and a more than type CF. Now, what is less than type CF? What is more than type CF? Let's understand this one by one. So let's consider the values here, and from this raw data, can we identify any value less than 0? No, we don't have, right? So the number of values is 0. Do we have any values which are less than 5? So yes. How many values are this? 1, 2, 3, 4, 5. We have 5 observations which are less than 5. So consider less than 10, right? So let's make some space here, and we write the values here 0 and 5. Less than 10, so we count all these values, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 values here. Now less than 15, so we will add these observations also in this data. So 1, 13, then 14, 15, 16, 17, 18, 19, and the remaining ones, right? After less than 20, these all observations will be included here, right? So 19 के बाद there's a 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So at the end we get the value of 30. But here we have the raw data. In our question, we will directly be given the grouped frequency distribution, where we will not know how many observations from 0 to 5 have been included, how many observations from 5 to 10 have been included, right? As a separate values हमको नहीं मिलेगी. So in such cases, we will not be able to count all the values. So how do we develop a less than type frequency distribution basis on the grouped frequency distribution that will be given to us as our question? Right? So to simply get the values of the less than type CF, these values that we have, these are nothing but the cumulative frequencies, which we call as CF. Right? So this is less than type CF that we are developing here. So let's see how do we use the table that we have as our question to develop these values. So less than 0 is definitely 0, less than 5. So we get 0 plus 5, that is equal to 5. So what we are doing now, next is less than 10. So less than 10 is 5 plus 8, that is equal to 13. See, what we are doing is we are just adding up these values. We are just adding up these frequencies to get our cumulative frequency, that is CF. Right? So next is 13 plus the next value. Now the next value is 6. So 13 plus 6, that is equal to 19. And lastly, between 15 to 20, so less than 20 will be 19 plus 11, that will be equal to 30. Now check the values we have got as the CF from not the raw data, but from the data that is given to us as the grouped frequency distribution, right? So this is how we will develop the column of the CF that is going to be used in our formula of median. हमारे median के formula में जो CF consider किया जाएगा, that will be less than type वाला CF, where the values will be obtained by just adding the frequencies that we have, right? looking at these values, this is more than type CF. Now how do we get these values? How do we get these values here, number of values here? So let's count more than 0. So more than zeros में तो ये सारी observations include कर दिए जाएंगे. तो कितने observations हैं ये? So we have 30. Now more than 5 में हमारे ये वाले ऑब्जर्वेशंस कंसिडर नहीं किए जाएंगे. सो ये वाले कितने ऑब्जर्वेशंस है? दीज आर द 5 ऑब्जर्वेशंस. तो 30 में से अब मोर देन 5 में ये ऑब्जर्वेशंस डिडक्ट कर दिए जाएंगे, सब्ट्रैक्ट कर दिए जाएंगे. सो वी विल बी लेफ्ट विद 25. अब नेक्स्ट मोर देन 10. सो मोर देन 10 में ये सारे ऑब्जर्वेशंस अब जो है हमारे कंसिडर नहीं किए जाएंगे. दिस ऑल विल बी सब्ट्रैक्टेड. इनफैक्ट अब मैं 25 में से सिंपली ये वाले ऑब्जर्वेशंस को अगर मैं सब्ट्रैक्ट कर दूं, सो वी विल हैव द नंबर ऑफ ऑब्जर्वेशंस दैट विल बी इंक्लूडेड इन मोर देन 10 विल बी 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17. So we have 17 observations. Let's count more than 15. More than 15 1 2 3 4 5 6 7 8 9 10 11. We have 11, and more than 20 mein we don't have any single observation, right? But again, as we discussed, the raw data will not be given to us. We will be given the grouped frequency distribution. So how do we get the values of this more than type CF basis on the given data, basis on the given table that we have, right? So in more than type CF, what we will do is, how many observations do we have more than 0? So all the observations are in the values of more than 0. So we will write the value 30 here. Now more than 5. So what we will do is, we will subtract these values one by one from the value here that we get as our answer. So 30 minus 5, that will be 25. What is the next value of the frequency that we have is 8. So from this value we will subtract 8 and we get our next value. What is the next value? 6. So 17 minus 6, that will be 11, and the next value is 11. 11 minus 11, that is equal to 0. See, how did we get these values of CF basis on the given data and not from the raw data? These are the values we obtained from the raw data, but we will not have this, and we will have the table from which we will get the CF of less than type and more than type this way. In less than type CF, we will add up the values, right? So this CF is going to be important when we are finding the mean for the grouped frequency distribution. Let's see. Let's take an example and solve a question related to median. So the following frequency distribution gives the monthly consumption of electricity of 68 consumers of a locality. Find the median, mean and mode of the data and compare them. So for this example, we are going to find the median and see how do we find the median, how do we get the value of median for the grouped frequency distribution. So we have the monthly consumption in units, which are given to us in the form of the classes. We have all the class intervals and the number of consumers that are given to us. These are our frequencies. So before starting this question and find the median for a grouped frequency distribution, we must find the CF, and we have to get the column of CF here. So how do we find CF? As discussed, we will add up the values of the frequencies to find the less than type wala CF here, right? So first is less than, let's consider less than 85. So less than 85, we will have how many numbers? Here we will have just 4. How many will be less than 105? So less than type CF, we will have 4 plus 5, that will be equal to 9. Then we will have next 13. So 9 plus 13, which will be equal to 22. This we are getting the values of CF. So next is 22 plus adding the next frequency, that will be equal to 42. Next is 42 plus 14, which will be equal to 56. And next 56 plus 8, which will be equal to 64, and finally 64 plus 4, which will be equal to 68. Now this final value should be equal to the final number of frequency, that is total frequency. It should match up with the total frequency that we have, right? So here n, that is the total frequency, is nothing but 68. So n is the number of observations that we have in this data, that is 68, and this is the column of the CF that we have here. Now let's see how do we use this, how do we substitute the values in our formula. right? So we have the table here as discussed. Further, here let's list down the values that we have. So here n is equal to how much? That is 68. So n by 2, which is 68 by 2, which will be equal to 34. And 125 to 145. Now here, very important thing is to get the median class. So what is median class? Again, median class is the class with CF, value of CF greater than n by 2. So let's look at the table here. And what is the value of n by 2? We have 34. So value of n by 2 is 34 here. When we are going through the values of CF column, here the value which becomes greater than n by 2. So 4 is not greater than 34, 9 is not greater than 34, 22 is not greater than 34, 42 here is greater than 34, right? We stop there, and this particular class corresponding to this CF will be our median class, right? So 125 to 145 is the class whose cumulative frequency 42 is greater than 34, right? So here 125 to 145 is our median class. Now once we get the median class, we get all other values, right? So L is the lower limit of the median class, that will be 125. What are all other elements in this formula? We have n by 2, which is we found as 34. CF is the cumulative class of the class preceding the median class. So CF हम कौन सी consider करेंगे? Not the CF of the median class, but the class preceding to that. So यहाँ पे जो CF हम consider करेंगे should be 22. So CF here should be equal to 22, CF of the class preceding the median class. F is the frequency of the median class. So median class हमारा 125 to 145 जिसका frequency है 20, this is to be considered. And H is the class size. What is the class size here? Upper limit minus lower limit. So 145 minus 125, that will be 20. We have all the required values here now to be used in our formula. So let's substitute the values in our formula and find median for this group data. So here median is given by the formula L plus we have n upon 2 minus CF whole upon F into H. Right, so let's use the values here that we have. So this is 125 plus n by 2, which is 34 minus CF value हमने यहाँ पे कौन सी ली है? CF, that is 22 upon F, that is 20 into H. We will cancel out 20 and 20, and 34 minus 22, which is equal to 12, and 12 plus 125 should be equal to 137. Right, so here the median of this particular data is 137. This is how we find the median of a grouped frequency distribution. Right, moving further, looking at the next example here now. Now here in this example, we are not given the grouped frequency distribution as we get directly, right? Now here what we are given is less than type CF distribution. Let's look at the example. So a survey regarding the heights in centimeter of 51 girls of class 10th of a school was conducted, and the following data was obtained. Find the median height. So let's look at the question. It says height in centimeters, which is less than 140, less than 145, less than 150, less than. Now this is not a normal grouped frequency distribution. यहाँ पे less than type आपको values दी है, right? So we first need to convert this into a normal grouped frequency distribution with the continuous classes and list down the values of the frequencies first. So let's look at the number of girls here: 4, 11, 29, 40, 46. If you look at this trend, this is increasing trend. Now here the number of girls, these are not your frequencies. This is the cumulative frequencies that we have, because this is a cumulative frequency distribution that we have. कैसा? Less than type वाला. So this is a type of question where you first have to convert this into a normal grouped distribution, right? So we have to develop the classes here based based on the given information. So first is less than 140, so we can take less than 140 here, but the next is less than 145. मतलब इस डेटा से यहाँ पे नेक्स्ट वैल्यू तक आते आते वी हैव लेस देन 145 मीन्स हियर दीज ऑब्जर्वेशन मस्ट बी फ्रॉम 140 to 145. Considering next less than 150 means these observations should be between 145 to 150. See how we are developing the classes here based on the less than type CF table, right? So this way we will get all the class intervals required, and let's see how do we get the frequencies of corresponding to these classes, right? So जैसे हम बात करते थे CF कैसे फाइंड करते थे, हम CF फाइंड करते थे by adding the frequencies. यहाँ पे CF से अब frequencies फाइंड करनी है तो हम क्या करेंगे, we will subtract the values from the next CF, we will subtract the values from the next CF. So यहाँ पे जो first हमारे पास number of girls के कॉलम में जो frequency है, this is CF which is our will be our first frequency corresponding to less than 140. Now between 140 to 145, less than 140 कितने थे, 4 थे. अब less than 145 कितने हो गए, 11, पर उसमें से 140 से कम तो कितने थे, 4, right? So 140 से 145 में इसका difference, that is 11 minus 4 should be 7. This is how we are developing our column of the frequencies, that is the number of girls here. Right, same way we will just keep subtracting the values here from the previous CF and we will get the values of our frequencies as required. Right, so let's look at the table and understand this. So to calculate the median height we need to find the class intervals and their corresponding frequencies as we discussed, right? So we have developed a frequency distribution table here and where we have the class intervals ready for us. Now we have to get the frequencies here. What are our values of the CF? This values of CF we can get from the question itself, right? So we have all the values listed here. Now we need to get the frequency, that is the number of girls corresponding to these classes. So as discussed, the first will be the same, that will be 4. Now between 140 to 145, how many girls were there? So this should be obtained by subtracting 4 from 11. So 11 minus 4 we get 7. Next value will be obtained by subtracting 11 from 29. Same way, next 40 minus 29 gives us 11. Now next should be 46 minus 40, that should be equal to 6, and the next should be 51 minus 46, that should be equal to, just a second, that should be equal to 5, right? So we have developed a frequency distribution, a grouped frequency distribution, and we have also got all the values of the frequencies required here. Now this is a normal table that we have obtained to find the median, right? So now we can find median class first and then we can obtain all the values required for the formula of the median, right? So here we will first calculate n by 2, that is total number of observations. Here is 51. The first thing after getting this table is to find the value of n by 2. Here in this case should be 51 by 2, that should be equal to 25.5. Now the next important thing here is to find the median class. As discussed, what is median class? Median class is the class with CF greater than n by 2. So let's look at the values of CF. So 4 is not greater than 25.5, 11 is not greater than 25.5, 29 is greater than 25.5. So the class corresponding to this CF should be our median class, right? So here our median class will be 145 to 150. I hope this is clear. Now next we will list down all other values. So lower limit of this class is 145. Now which CF should we consider here? We should consider the CF. Now for our formula we should consider the CF of the class preceding the median class. So the class preceding the median class is 140 to 145 और इसका जो CF होगा वो हमारे फॉर्मूला के लिए CF हम कंसिडर करेंगे, right? F should be the frequency of this median class, that is 18 here, and H is our class size, which is 150 minus 145, that is equal to 5. So we have all the values required for our formula, right? So let's solve this question and let's substitute these values in our formula of median and get the value of median. Just a second. So we have the frequency distribution table here with the CF, right? So here let's list down the values again very quickly. So n was 51, n by 2 is 51 by 2, that is 25.5. In cumulative frequency, we can see that this observation comes after 11. This observation comes after 11 and before 29. So it lies in the class, 145 to 150, right? So then here the lower limit L is 145. We have the cumulative frequency of the class preceding the CF किसका देखना है? Median class के पहले वाले class का, right? So this should be equal to 11. Frequency of the median class F हम consider करेंगे same class का, median class का, that is equal to 18. Class size H is 5. Right? So using the formula of median, that is L plus n by 2 minus CF upon F into H, we have, let's use and substitute the values here. So L is 145 plus n by 2, that is 25.5 minus CF, that is 11, and upon F we have listed down as 18 into 5. So 25.5 minus 11, that will be 14.5. 14.5 into 5, that will be 72.5. So 72.5 divided by 18. So 145 plus, as discussed, don't waste your time by doing the LCM here. Solve this particular fraction quickly, get your answer in decimal form and add it to 145. So when we solve this, we will get 145 plus 4.03, and your final answer here should be equal to 149.03. So here the median height of the girls is 149.03, right? So this is how we will deal with how to find median for a distribution which is in the form of a less than type cumulative frequency distribution form, right? We converted it first to a normal group frequency distribution and then we found median as per the process. Now moving further, the questions of these mean, if we talk about finding the missing frequencies of the mean, are expected around 3 marks, but there are questions where you have to find the couple of missing frequencies from the data, right? These kind of questions are included in the median. You will be given the value of median, you will be required to find 2 missing frequencies from the data. Generally, usually these kind of questions are expected in 5 markers and very important questions, right? So let's look at one of the examples here where we need to find the missing frequencies where the median of the data is already given. The median of the following data is 525. Find the missing values. In this data, we have X and Y, which are our missing frequencies. If the total frequency is 100. Here in these kind of questions you will be given 2 information. First information जो आपको already दी जाएगी, that is the value of median, and second information जो आपको already दी जाएगी, that is the total number of frequencies, total number of observations, that is your frequency. Frequency आपको दे दी है, median आपको दे दिया है. Now how to find the values of missing frequencies X and Y? Let's look at this question, let's look at this example and solve this. So we have the class intervals here, we have the frequencies here. Now the next first step that we will do here is develop the column of the cumulative frequency and list down all the values of the cumulative frequencies, right? So first का हमारा जो CF का value होगा, that will be same as your frequency. Next value of CF will be obtained now by adding up the values of the frequencies, right? So here 2 plus 5, that will be 7. Now next is x, so we will write 7 plus x. Next is 12, so 12 plus 7, that is 19, and we get here 19 plus x. Next is 17, so 19 plus 17, we will get 36, so we get here 36 plus x. Next is 20, we add 20 to 36, we get 56 plus x. Next is y, so we add another variable here, 56 plus x plus y. Next is 9, so we add 9 to 56, that is 65 plus x plus y. We have 7 here, so 65 plus 7, we get 72 plus x plus y. Finally we have 4, we add 4 here to 72, we get 76 plus x plus y, right? Now as we discussed, this value 76 plus x plus y, this final value, the last value in our CF column, should be equal to your total frequency, that is should be equal to n. So what is the total frequency here? It is 100. So n is equal to 100. In fact, if I add all these values of the frequency, I get n equal to 76 plus x plus y, right? But I'm already given that n is equal to 100. So I will compare this value, the value of n that we obtained by adding the values of the frequency, with the value of n already given to us in our question. And using both this, comparing both these values, we will get an equation, a very important equation, right? So let's see. So this is the cumulative frequency table and the column that we developed, and this is the table that we have now. As discussed here, if we add all the values of the frequency, we get n equals to 76 plus x plus y. Now we already have n equals to 100. It is given that n equals to 100, right? So the value that we have from the table is 76 plus x plus y. So the value of x plus y should be equal to 24. This is the equation that we will use in the end. Once we get the value of one variable, we will substitute the value of one variable that we get to find the value of another variable through this linear equation that we have obtained here, right? Further, the median is 525, which lies in the class. So here, this is about finding the median class. This is about finding the median class. So in previous examples that we saw, how did we find the median class? It was the class with CF greater than n by 2. There we had the specific value of the CF that we had. But here in this CF column, we don't have the proper specific values. In fact, we have the variables here, so we cannot predict the values, proper values here, right? So how do we find the median class here? We find the median class by looking at what is the median. Now median that we obtain is obtained from the median class only, right? So this value of median 525 should be between this class 500 to 600. 525 lies between 500 to 600, right? That is the value of median. So 500 to 600, in which our median lies, is our median class, right? So here, which lies in the class 500 to 600, which becomes our median class. Now basis on this median class, what should be the value of L? It should be lower limit, that is 500. Now considering this table, considering this median class, what should be the frequency? This should be the frequency of the median class. What should be the value of CF? CF should be considered for the formula. CF should be considered for the class preceding the median class. So is class 400 to 500 ka jo CF hoga, that will be our CF. So here F is 20, CF is 36 plus x, and h, that is the size of the class interval, which is 600 minus 500, that is equal to 100. So we have all the values required for our formula. Let's substitute these values in our formula. So formula is median is given by L plus n by 2 minus CF upon F into h. Substituting the values, we get median का value क्या दिया है 525, our value of L is 500, n by 2, that is n is equal to 100. So n by 2 का value should be equal to 50. So value of n by 2 here we substitute as 50 minus CF. So 50 minus 36 plus x, and if I solve this bracket I get 50 minus 36 minus x. So that's why here 50 minus 36 minus x divided by 20, which is our frequency, into h our size, right? So next is, how do we solve this particular problem? How do we calculate this very easily? Is first we will substitute this value 500 to the LHS part, and we will try to simplify this as much as possible, right? So next step is we substitute 500 to the LHS part. So 525 minus 500. Here we simplify this. 50 minus 36 is equal to 14 minus x, and we cut here 21s are 25s are, so this should be equal to 5. Now the value of 525 minus 500 is 25 here, and we multiply this bracket with 5, we get 14 5 is 70 minus 5x. Now this is a simple linear equation in one variable, which we should be able to solve by just transposition, right? So here 5x should be equal to 70 minus 25, and which should be equal to 45. So the value of 5x is 45, so value of x should be 45 divided by 5, so the value of x should be equal to 9. Right? So how easily we got this value of one variable x by substituting the values that we obtain in the formula and doing the calculations smartly. Further, from this equation that we got, the first equation that we obtained was x plus y equals to 24. Here we have two variables, linear equation in two variables, where we have the value of one variable now, that is x, that is 9. We will substitute here. So 9 plus y is equal to 24, and the value of y should be equals to 24 minus 9, that should be equal to 15. So we have solved this equation to get the value of y. This is how we get the values of both the missing frequencies, both the missing variables, with the help of the value of the median given in our question, with the help of the value of the total number of observations, that is the frequency given in our question, right? As we discussed, this is a very important question. So let us discuss one more question here based on the missing frequencies, based on the missing values of x and y. Now let's discuss a very important question which is usually expected for 5 marks, which is to find the values of the missing frequencies from the given distribution, right? So here in this frequency distribution, if we can see that we have the values of the frequencies given, where we have two missing frequencies. We have two missing frequencies, and we have to find those missing frequencies with the help of the value of the median that is given to us and the value of the total frequency which is given to us, right? So here we have the class intervals, we have the values of frequencies, where we have two missing frequencies x and y in our data, right? So let's see, how do we find these missing values, these missing frequencies x and y, with the help of the given data of median, with the help of the given value of the total frequency, right? So first let's list down the values of the CF column here by adding the values of the frequencies that is given to us. So for the first row that we have for the CF is the value will be same as the frequency of that class, that is 5. Now the next here CF will be obtained by adding the frequencies. So this will be 5 plus x. Next 5 plus x plus 20, that is 20 plus 5, that is 25 plus x. Next 25 plus 15, that is 40 plus x. Now we have another variable here y, so this will be 40 plus x plus y. Next is 5, so we have 45 plus x plus y. Now this particular value that we have obtained as our last value of the CF column should be equal to the total number of observations, as we discussed, right? So here we have the total number of observations, that is sum of the frequencies that we have from the table is 60, but the total number of observations that we have from our calculations is 45 plus x plus y. and it is given that the total frequency is 60, thus n equals to 60. Right? So now we will compare these values and form a linear equation in two variables, which will help us at the end to get the value of the another missing value of the variable. Right? So we have 45 plus x plus y equals to 60, and we transpose this to get 60 minus 45. So value of x plus y is equal to 15. This is the first equation that we have. We have the two missing variables here, x and y. So we have developed the linear equation in two variables, x plus y equals to 15. Now here the value of n by 2 should be obtained first. So n by 2 is equal to 60 by 2, that is 30. Next important thing here is to find the median class. So median class, so median that is given to us already is 28.5. Now to find the median class, this median must be obtained from the median class only. So the value 28.5 lies between which class? It lies between 20 to 30. So here that's why 20 to 30 should be our median class. Right? Now once we have this median class, we can obtain all other required values which are important and can be used in our formula. So here, as we have 20 to 30 as our median class, we can identify the value of the frequency, which should correspond to the median class directly. The value of CF that we should consider should be of the CF that should be of the class preceding the median class, right? So let's list down the values here. L is the lower limit of the median class, that is 20. Frequency of the median class is again 20. Next, cumulative frequency, CF, to be considered here should be the class preceding the median class, that should be equal to 5 plus x here, right? Next is class size, that is h, that is 30 minus 20, we should get 10 here. Now using these values, substituting these values in our formula, let's find out the values of both x and y. So the formula of median here is L plus n by 2 minus CF upon f into h. Right? So median ka value that is given to us 28.5, L that we have listed here, that is 20, plus n by 2 30 minus CF. What is CF here? We will write it in bracket carefully and not make any calculation mistake here. This is a binomial, should be written in the brackets. So to avoid the sign mistake, 30 minus 5 plus x upon f ka value we have listed as 20 into h that is the class size, which is 10. Right? So as we discussed here, for this particular calculation we will transpose the value of the lower limit to the other side and get the value first and simplify this particular fraction here on the RHS part only to make our calculations easier. Right? So further, so we have 28.5 is equal to 20 plus 30 minus 5 minus x whole upon 2. So here what we will have is, we will transpose this value of 20 here. So 28.5 minus 20 should be equal to 30 minus 5, 25 minus x by 2. Subtracting this on the LHS part, we get 8.5 is equal to RHS as it is brought forward. Now transposing this value of 2, 8.5 into 2, we get 17, which should be equal to 25 minus x, and transposing the values and the variable on the other side, we get x should be equal to 8 here. Right? We have got the value of one variable. Now we need to get the value of the other variable, and now this value of other variable we can obtain with the help of the linear equation in two variables that we obtained earlier. So substituting this value of x equals to 8 in the first equation, x plus y equals to 15, substituting this value of x, 8 plus y equals to 15. Now we can get the value of y by transposing the value 8. So y equals to 15 minus 8 and y equals to 7. Hence, we have obtained both the values, both the missing frequencies x and y in such a way. We first developed the linear equation basis on x plus y, and we substituted the value of one variable to obtain the value of another variable. I hope all the concepts of this particular chapter are clear to you. We are clear with mean, median and mode so far. Further, a very important thing that is also given in our textbook is an empirical relationship. So we have the empirical relationship between the three measures of central tendency, that is mean, mode and median, which is given by this formula, that is 3 times median is equal to mode plus 2 times mean. इसका कोई क्वेश्चन हमारे टेक्स्ट बुक में नहीं दिया है, बट दीज काइंड ऑफ क्वेश्चंस आर फ्रीक्वेंटली आस्क्ड इन द ऑब्जेक्टिव्स पार्ट, which are also a part of our Keystone Objectives book, right? So we should now look at some examples कि किस तरीके के questions इस empirical relationship के basis पे पूछे जा सकते हैं. So look at several examples here. So first example, we have, if the value of mean is 60 and the value of mode is 30, then find median using the empirical relationship. So we just saw what is the empirical relationship between mean, median and mode. Let's apply that. Let's substitute the values of mean and mode and get the value of median basis on using this empirical relationship. So we know that by empirical relationship we have 3 times median is equal to mode plus 2 times mean. So we need to find median here, and we have the values of mode and mean here. So value of mode we substitute here as 30 plus 2 into 60. So we get 30 plus 120, which is equal to 150. Now this is the value of 3 times median. So we can get median is equal to 150 upon 3, and the value of median that we obtain by empirical relationship, by using empirical relationship here, is equal to 50, right? Let's look at one more example how to find. So if any of the two values, either of mean or of mode or of median, are given to you, you can find the third measure of central tendency by using the empirical relationship. Let's look at one more example. If the median of the given distribution, this time we are given the median and the mean is given to us as 22.5, find the mode using empirical relationship. So using the empirical relationship, we know that 3 times median is equal to mode plus 2 times mean, right? So we have mode should be equal to 3 times median minus 2 times mean. Why this? Because we need to find mode basis on the given values of median and mean. Now we substitute the values of median and mean here. We get 3 times, that is median, which is 20 minus 2 into the value of mean that we have is 22.5. So this should be equal to 60 minus 45, which should be equal to 15. So we have got the value of mode here with the help of empirical relationship on the basis of the given values of median and mean. Now let us quickly revise the concepts and the formulas related to all 3 measures of central tendencies. First, talking about mean. Mean means average, and we saw that the mean for a grouped frequency distribution can be obtained by 3 methods. The first is direct method, second assumed mean method, and third step deviation method. We saw that what kind of method should be appropriate for what kind of situation. So we discussed that if the numerical values of the observations and the frequencies is small, we will use direct method, and if the numerical values of observations and frequencies are large, we can use assumed mean method or the step step deviation method, whichever method is appropriate, right? Talking about the direct method, we can obtain mean by the formula sigma fi xi upon sigma fi, where sigma shows summation and numerator is sigma fi xi, which is a summation of all the values of fi into xi, where xi is the class marks, which is obtained by upper class limit plus lower class limit divided by 2, and the denominator is sigma fi, which is the summation of all the values of the frequencies. Second is assumed mean method. The formula is a plus sigma fi di upon sigma fi, where a is the assumed mean taken from the central value of all the values of the class marks, right? And sigma fi di, where di stands for deviations, which is xi minus a, that is subtracting the value of assumed mean from the class marks. And the third is step deviation method. The formula is a plus sigma fi ui upon sigma fi into h, where ui is di upon h, di is the deviations xi minus a divided by h gives you ui, and h stands for size of the class interval, that is the height of the class, right? Talking about mode, we saw that the mode is the observation with the highest frequency, and for the grouped frequency distribution for mode, we first find out the modal class, and we saw that the modal class is the class with the highest frequency. Formula to find the mode for the grouped frequency distribution is L plus f1 minus f0 upon 2f1 minus f0 minus f2 into h, where L is the lower limit of the modal class, f1 is the frequency of the modal class, f0 is the frequency of the class preceding the modal class, f2 is the frequency of the class succeeding the modal class, and h is the size or the height of the modal class. Talking about median, we saw that median is the middlemost observation for the ungrouped data, and for the grouped frequency distribution, the formula to find median is L plus n by 2 minus CF upon f into h, where we should first find the median class, and median class is the class with CF greater than n by 2. What is CF? CF is the cumulative frequency, and we get the number of the values of the cumulative frequencies by adding the values of the frequencies. And L here is the lower limit of the median class, n by 2 is the n by 2 is half of the number of total observations. CF here in the formula is the CF of the class preceding the median class, right? F is the frequency of the median class, and H is the height of the median class. And lastly, talking about very important topic, that is empirical relationship between three measures of central tendencies, that is 3 times median is equal to mode plus 2 times mean, right? So all the best everyone.